Hello everyone, welcome back to a new session of object-oriented programming on polymorphism. If inheritance was about reusing code, polymorphism is about making it flexible. It is the magic that allows a single interface to handle an infinite variety of actions. This is arguably the most important concept for building scalable professional software. Let's dive in. First, let's break down the word. It sounds complex, but it comes from two simple Greek roots: poly, meaning many, and morphs, meaning forms. In the world of Java, polymorphism is the ability of an object to take many forms. It allows us to define one actions like move or draw and execute it in different ways depending on the object is performing it. It's all about providing a consistent interface for different underlying implementations. The best way to understand this is to look at yourself. You are a single object, a person, but your behavior changes based on your context. When you are at the office, you act as an employee. When you are at home, you behave as a parent or a child. In a shopping mall, you act as a customer. You are the same object, but you take different forms or behavior depending on where you are. That's polymorphism in a nutshell. In Java, polymorphism is split into two distinct categories. The first is the compile time polymorphism, also known as static polymorphism. This is achieved through overloading. The computer knows exactly which version of the method to call while it's compiling your code. Second is runtime polymorphism or dynamic polymorphism. This is achieved through overriding. Here overloading and here it's overriding. Here the computer doesn't decide which method to call until the program is actually running. This is the more powerful of the two. Let's look at method overloading. This happens with the same class. Look at the method class math op on the screen. We have two methods named add. One takes two numbers and the other takes three. This is overloading. The compiler looks at your arguments. If you pass two numbers, it calls the first one. If you call three, it calls the second. It's simple, clean, and prevents you from having two methods like method, add two numbers, and add three numbers. Now, method overriding is where things get interesting. This happens between a parent and a child class. Imagine a parent class animal with a method speak. A dog inherits from animal but provides its own version of speak to say bark. For this to work, the name and the parameter must be exactly the same. You are essentially replacing the parent's generic behavior with the child's specific behavior. How does the computer handle this dynamic behavior? Through a concept called upcasting. Look at this line, parent object is equal to new child. Here we use a parent reference variable to point to a child object. When you call a method on object, the JVM performs something called dynamic method dispatch. This ignores the reference type and looks at the actual object in memory. If the object is a dog, it barks, even if the variable type is just animal. This is the core secret of polymorphism. This table is like a gold mine, and it's really very important to remember this. Overloading is early binding because it happens at compile time. Overriding is late binding because it happens at runtime. Overloading requires different parameters. Overriding requires the exact same parameters. And return type can be different in overloading. Return type must be the same. Why do we bother with all this? First, extensibility. I can add a new cat class to my program tomorrow, and my existing code, which just tells animals to speak, will work perfectly with the new cat without me changing a single line of code from the original logic. It makes our code cleaner, more generic, and incredibly easy to maintain. It follows open code principle. Your code is open for extension but closed for modification. Watch out for these traps. Students often try to override a static or private method. You can't override a static method belonging to the same class, not the object and The private method aren't even visible to the child. Also remember that you cannot change a final method. Java ignores the written type when overloading. If you have two methods with the same name and parameters but different written type, your code will fail to compile. To recap, polymorphism means one name, many forms. Overriding is dynamic. Upcasting allows parent reference to trigger child behavior. If you master these, you are well on your way to becoming a professional Java developer. If an interviewer asks, what is dynamic method dispatch? Then just tell it's the process where a call to an overridden method is resolved at runtime. Can we override the main method? The answer is no because main method is static. Difference between early and late binding. Early binding takes place during the compile time and late binding takes place during the runtime. These are the important points to be remembered. Thank you for your time and happy coding.